Hi everyone! Today we're going to do an overview. You're going to watch a flip-a-clip about Chapter 14, Thalassemia. Okay, we've discussed the breakdown of the red blood cell and recycling of hemoglobin into the heme and globin portions. So we've talked about the anemias dealing with disordered iron and the heme portions of the hemoglobin molecule. Now we need to move on to the globin portions. And we've also discussed the qualitative or structural defects known as hemoglobinopathies. Today, we're going to discuss the quantitative defects of the globin chain called thalassemias. Thalassemias are a group of genetically inherited disorders classified by their decrease or absent production of the affected globin chain. There are over 400 different types of mutations. Okay, let's review. Okay, since we know that thalassemias are a genetically inherited trait, we know the globin chains are produced on either chromosome 11 or chromosome 16. On chromosome 16, you get two sets of inherited alpha chains from each parent. On chromosome 11, you get one set each of inherited beta, gamma, or delta chains, producing normal hemoglobins, hemoglobin A, hemoglobin F, and hemoglobin A2. So since there are over 400 mutations for thalassemias, we're just going to focus on the absence or decrease of the alpha and beta chains. So normally, the alpha and beta chains are produced in a ratio of 1:1. Let's take alpha thalassemia, for example. In alpha thalassemia, you have a genetic mutation that prevents the body from producing alpha chains. So due to an absence or decreased synthesis in the alpha chain, you have an excess of beta chains, which causes another abnormal hemoglobin. This abnormal hemoglobin contributes to decreased red cell production of hemoglobin, ineffective erythropoiesis, and chronic hemolysis. Depending on the severity of the alpha thalassemia, there could be excess gamma chains as well. This abnormal hemoglobin is called hemoglobin Bartz and creates a tetramer of 4 gamma chains. Now let's talk about beta thalassemia. Beta thalassemia is named because there is a decrease or absent synthesis of the beta chain. Although in alpha thalassemia there was an excess in beta chains creating abnormal hemoglobins and excess gamma chains creating abnormal hemoglobins, here with the excess alpha chains in beta thalassemia, they are very highly insoluble and precipitate in the cell, cause damage right away, so they do not make a tetramer. Instead, depending on the severity of the beta thalassemia, you may have decreased or absent hemoglobin A and increased A2 and hemoglobin F. There will be another recording on the genetics and the clinical manifestations of thalassemias. I want to thank my son Gabriel for helping me create this flip-a-clip for you guys.